A big matter being made in the science world today over the existence of antimatter. Canadian scientists are responsible for a big advancement with some very tiny particles. Joanna Remiliotis looks at the significance of the discovery and why it's upping the ante for other scientists.
It's a theoretical relationship between time and antimatter.
Captain Kirk and the Starship Enterprise wouldn't have gone far without it, or nearly as fast.
The antimatter is suspended there.
And if it wasn't so elusive, it wouldn't be the stuff a Hollywood holy grail is made of. Antimatter. More fantasy than reality, until now.
These electrodes go into this cylinder inside the antimatter trap.
Makoto Fujiwara calls it a universe game changer. He's holding a replica of a piece of science history, a container that can trap atomic antimatter for 16 minutes. Until now, scientists could barely contain it for nanoseconds.
We feel a little bit of a historic significance in being able to contain antimatter for a long period of time. So this is the first time it's ever been done, perhaps anywhere in the universe.
The theory behind the Big Bang, or the beginning of time, is that the early universe was a product of equal amounts of matter and antimatter, two polar forces that annihilate each other on contact. The universe, or matter, is still around. The antimatter vanished, leaving scientists and science buffs wondering whatever happened to the so-called lost half.
I'm just fascinated with life, so the more I know about life, or how it works, or what makes it tick, is of interest to me.
Maybe it'll bring an understanding of something that'll put the pieces together, because there's so many things in our life that really aren't even explained to this day.
Kim Tate is with the Royal Ontario Museum.
This is a really big deal. I mean, this is the first time they're actually able to look at this material. So this is going to answer fundamental questions. Just where did we come from? Where did the universe come from? What are we made up of?
Scientists first created large amounts of antimatter about a decade ago. But trapping antimatter long enough to actually study it, that's been the tricky part. That's where a special canister, roughly the size and shape of a water bottle like this, comes in. In Geneva, in the only laboratory in the world suitable, the team of researchers, many of them Canadian, spent 5 years creating this. A cylindrical container that uses magnets to keep antimatter atoms away from matter that would cause their destruction. It's a quantum leap in terms of what it could mean.
If the matter and antimatter are exactly the same, we wouldn't be here. So we better understand. Well, like at least we like to understand, how is it that we came about.
The plan now, as ambitious as the first, to capture antimatter for even longer and to begin to unravel a mystery that has eluded science literally since the beginning of time. Joanna Remiliotis, CBC News, Toronto.